today's lesson. Today's lesson is about trig functions, and we were talking about trig functions basics in the lesson before. We are on lesson 7 of 8. So those of you who are joining us for the first time today, you are joining us 6 lessons in. Okay, so lessons 1 to 6 can be found on our website right underneath today's lesson, and you can go watch those to catch up on everything we've done on functions. We've covered the straight line, the parabola, the hyperbola, the exponential graph, and we're finally looking at trig functions. But today isn't the first time we're looking at trig functions. We'd already talked about the basics, so I'm going to take this part out. We've spoken about the basics of trig functions, right? Now, we're just going to be extending today's lesson to just include the things that we need to know about trig graphs, right? And we learned that if we want to draw any of the graphs, and these original graphs that we have over here of sine x, cos x, and tan x are called our mother graphs. We call them mother graphs, okay? We call them mother graphs. And the reason we call them mother graphs is because whenever another graph is drawn, let's say, for instance, they draw another graph like over there, like that, we need to be asking ourselves, if this is the kind of graph that they've drawn, what have they done? What did they do? What did they do to the mother graph? Okay, that's the question we're asking. What did they do to the mother graph? I remember somebody asking, I think it was Takane asking, ma'am, is there a father graph? No, guys, there's no father graph. Okay, there's only a mother graph. Okay. All right. So we need to ask this question. When we're looking at our graphs, no matter what it is we're looking at, we need to ask ourselves, how did they change up the original graph? What did they do to it in terms of where we're going? Now, remember, when we draw our mother graphs, we always need to consider a certain couple of points, right? We need to consider the point 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, okay? And we said that we would stop at 360 for our sine and cos graph, because after we hit, if we go any further than 360 degrees, we start repeating the same graph again. So there's no need for us to draw a graph beyond 360 degrees, because once we start going 361, we're drawing the same kind of thing again. So when we look at the graph of a sine graph, we know that 360 degrees is our period, right? Our period. And we said that the period is how long it takes for us to draw a full graph. Normally it takes us 360, right? So I want to ask you guys, if I had to draw a graph, right? If I had to draw a graph, and in 360, I managed to add 2 graphs. I managed to add 2 graphs. What is my new period? How long does it take me to finish one graph? If I can draw 2 graphs in 360, what is my new period? How long did it take me to finish one graph? You can pop it in the chat. You can raise your hand if you want to ask a question or answer the question for me. Okay. If we look at what ma'am has drawn on the screen, how many graphs did I fit in that 360? I fit 2 graphs in. Right. So how long did it take me to start at 0, go up, go down, and back up at 0 again? I'll give you a hint. Yes, Gia, we drew it 2 times, but what is my new period if I can draw 2 graphs in 360? Refilwe, you've got the right idea. Guys, how long did it take me to draw this one graph? I went from 0 to 180. That's how long it took me. It took me 180. Good. My new period is now 180. Okay. It's 180. Okay. But if I had to ask you guys, how many graphs did I fit in 360? how many graphs did I fit into 360? Yes, Isayan. How many graphs did I fit in 360? You can unmute for me, my sweetie. Hello.
Ma'am, I'm still lost as to why the period is 180. Can you just explain that again?
Okay, absolutely. All right. So don't go away. Don't mute. I just want to make sure you're understanding me here. All right. Do you agree with me that to get from this point to go up and down and back to that point takes us 360? Yes?
Yes.
Okay, cool. So now I'm telling you that I'm going to fit 2 of these graphs in 360. I'm going to put 2 of these graphs in the space where I would normally draw 1 graph. Okay, so if I want to add 2 graphs into this space, where does 1 graph end? If it started at 0 and I've put 2 graphs in, where will my first graph end?
180.
That's it. Do you see now why the period has changed to 180?
Yes.
Okay, I hope that makes sense. Okay, awesome stuff. Nice question. I appreciate that question. Awesome. Keep those questions coming, guys. If you don't understand, keep asking those questions. All right. So what we're saying, guys, is the original mother graph of a sine graph normally has a period of 360. But if I draw 2 graphs in, my period will then change to 180, because now if I fit 2 graphs in, I'm going to finish the graph in half the space. I'm going to finish the full graph at 180. That's why my period now starts change to 180. How many graphs can I fit in 360? I can fit 2 of them. Yes, Kutlwano. Hello, Kutlwano. You can swipe left or right. You'll see a nice big speak button and you can unmute and speak to me, Masudi. No worries,
Ma'am,
Maya.
I don't understand. Hello,
Okay.
ma'am.
Hello, Masudi. Where did I lose you? Where did I lose you?
From the, like Matomo, ma'am.
Sure, from the beginning. How? Okay, all right. You're going to have to take out your calculator. Kutlwano, are you joining us for the first time today?
Yes.
Oh, okay, that's why. All right, Kutlwano, I'm going to ask you to grab your calculator for me. You've got your calculator with you?
Yes, ma'am.
Okay, excellent. I'm going to ask you to mute for just 2 seconds, and then we're going to speak about what's actually happening as we go. All right. So mute for me and keep up with me as we go. All right.
Okay. Okay.
All right. Excellent. Thank you, Teacher Nels, because that's what I was getting at actually. All right. So when we are drawing a graph, guys, whenever we draw our mother graph, we are going to put these points into our calculator. So we're going to substitute the x for 0. And you're going to find that if I put in sine 0, I'm going to get 0. So I'm going to put my point on the y-axis as 0. If I put in sine of 90, I'm going to get 1. So at 90 degrees, I'm going to put a point at 1. You can try this on your calculator, as long as your calculator is in degrees, because if it's not in degrees, we're going to have a bit of an issue. All right. Then if I go to sine of 0, sine of 180. So I'm going to replace x with 180 on my calculator. So I'm going to type in sine 180 close brackets. My calculator is going to give me the answer 0. So I'm going to put a dot at 0. No problems, Tariro. Welcome. All right. And then I'm also going to do the same with sine of 270. And my calculator is going to say -1. So I'm going to go to -1 on my y-axis. And I'm going to join where 270 and -1 join. And then I'm going to put in sine of 360. And my calculator is going to say 0. And this is what we're going to get. We're going to get all of these points. And if we join the points, they're going to give us this lovely graph that you're looking at over here. Okay. So if you put them into your calculator one after the other, this is what you're going to get for your mother graph. But now, if we go to our calculator and I want us to find the function of y is equal to sine of 2x, what this graph is telling me, the sine of 2x, it's telling me that I can fit 2 graphs into 360 degrees. Now, I'm going to ask you guys again. If I can fit 2 graphs into 360, what is the new period? What is the period? If I can fit 2 graphs into 360, what is the new period? Nkechi and Kimotoko. Excellent, guys. That's it, Lindoguhle. It's going to be 180 because I finish a full graph at 100 from 0 to 180, and then I can put another graph in there. We can put another graph in there. So my new period, if I add a number over here, tells me how many graphs can I fit into 360. Give me a thumbs up if that makes sense. Give me a thumbs up. Excellent, guys. Amazing stuff. That's it, Makhatse. Well done. Awesome, awesome, awesome. All right, everybody's with me here. Now, remember that the cos graph is going to be about the same as the sine graph, right? How long does it take me to finish a full cos graph? How long does it take me to get from 1, go down and come back all the way to 1? How many degrees does it take me? How many degrees does it take me to get all the way back to 1? Oh, Warona, it's not going to be 270. It's definitely not 270. There's my 270 mark. There's my 270 mark. How long does it take me to get from here all the way down and all the way back up to 1? It takes me 360 degrees. Okay. So I'm going to then ask you guys, if I go from 1, go all the way down and back up, what is the period of my cos mother graph? What is the period of my cos graph? While I take Nonkanka's question. Hi, Nonkanka. Hello. You're going to have to unmute for me, my sweetie, and we can talk. Okay. All right. Until then, we're going to wait for you. When you're ready to unmute, we'll have a conversation. Good. So it's going to take us 360. I know my mother graph isn't so great. It's quite tiny. Let me see if I can make it just a little bit bigger. There we go. That's better. All right. So we can see to get from 1 all the way to 360, all the way back to 1 takes us 360. Refilwe, not 180, 360. That's how long it's taking. She's breathing. We're glad, Kama. Nice to have you with us. Hello. The Slay Queen herself is in the house, everyone. All right. Ay, Ginger. Okay. All right, guys. So it takes us 360 to get from 1 and go down and come all the way back to 1 again. So the period of a cos graph is also 360. Now, if I take my cos graph, guys, and I write here, y is equal to cos of 3x. Okay, I'm going to ask you guys the question. How many graphs, you guys, I didn't even finish my question. You guys are cheating. How many graphs can I fit into 360? Good, 3 of them. Now, if I have to ask you guys, if I can fit 3 of them into my 360, what is my new period? What is the period? What is the period? If one of them is 360 and I need to fit 3 of them into 360, what is that going to be? For those of you who are saying 90, check your calculations again. Hello, Aneto. I think Aneto's joining us for the first time. Hi, Aneto, welcome. Welcome to Watobe. Excellent. It's 120. It's going to be 120 degrees. So what's going to happen is I'm going to draw a full graph. That's 1. A full graph. That's 2. And you're gonna forget that ma'am can't draw a full graph. That's 3. So to get from, let me draw that a little bit better. All right. So to get from 1 back to 1 again, it's going to take me 120 degrees. Okay. And I'm going to explain just now, Isayan, how I get 120 degrees. Okay. So when we want to find the period of a graph, let's say, oh, don't be that guy. Don't be that person. I know my graphs are not graphing. The waves aren't waving. Okay. So when we want to find the period, guys, when we want to find the period, we are going to take this number, the number in front here and the number in front here, and we're going to go 360 degrees divided by this number here. So in our sine graph, we said 360 divided by 2 because we could fit 2 graphs. And our period was then 180 degrees. Now, if I want to find the period of my new cross graph, I'm going to go, period is equal to 360 degrees divided by that number, divided by 3. And that's going to give me 120 degrees. Okay, so we're going to make a quick note of that. All right. When we calculate for the period, right, of a graph, let's say, for instance, we have, and let's say this, I'm going to make it y, a sine x graph. So I'm going to go y is equal to sine of some number, let's call the number bx. Okay. If I want to find the period, I'm going to take 360 degrees and I'm going to divide it by this number over here that's in the place of b. Okay. Give me a thumbs up if that makes sense. Can we see how we're going to calculate for the period? That's it, Makatsi, excellent. Good, Nkechi, that's it, Onako. Well done, Kimutlutu Engineer. Excellent. So if we want to find the period of a graph, we're going to take whatever number is sitting in front of the x, 360 divided by that. Hi, Anotida. Awesome to have you with us again, my dude. Okay. Excellent. Let's talk about the amplitude. All right. Let's talk about the amplitude. Now, the amplitude is basically that's okay, Anutida, that's okay. Aisha, ma'am, won't it change to tan instead of sine? No, my sweetie. So the only time it will change to tan is if I have sine over cos, and that's not what I have, my sweetie. I don't have sine over cos. Okay. I'm sorry, Kama. Mama's making us a segue, but it's the funniest segue I've seen in a long time. I'm sorry, my sweetie. I'm so sorry. All I see is clown. Cheers. That's how I felt the one day when I wrote chemistry, but I was in university. It's a story for another time. Oh, Didi, no worries. Teacher Nelly, can we maybe send a message to the WhatsApp group and let them know that a lot of kids had trouble logging in today?
No, they already know because they sent a message on the group.
Oh, did they? Oh, is it just me who's not reading my messages? Okay. Okay.
They did say that we're gonna have like a lot of students coming in late today.
Oh, okay. All right. No worries. Phew, I'm sorry, guys, for those of you who are late. That's okay, Shaden. No worries. Okay, guys. So we were talking about amplitude. Come back, guys. Come back. Come back. All right. Whew. Okay, so we're talking about the amplitude. So the amplitude is going to be how far up my graph goes. So we can see from 0, how far up did my graph go, guys? From the point 0, how far up did my graph go? That's it. 1. It went up 1. It went up 1. And that is the amplitude. Finish and clap. We're not going to speak about the amplitude again. Amplitude is how far up from 0 did my graph go? All right, that's the amplitude. Okay, but I don't want to say just from 0. Okay, I don't want to just say from 0 because sometimes, guys, they will take my graph and they will move it there. Right, and if they move my graph over there, now this is my middle point. This is my middle point. If my graph is drawn like that, if my graph is drawn like that, how far up, if my graph went from -1 to 1, how far up did my graph go, guys? From here, count that as 1 unit, count that as another unit. How far up did my graph go this time? That's it, Nkandla Onako Chifaro, excellent. It went up 2. So the amplitude is always where my graph goes from the middle to each side, but it gets kind of complicated, guys. It does get quite complicated, okay, when we're trying to figure this out. So here's what we're going to do. We're going to do this. We're going to take our maximum point, which is 1, and our minimum point, which is -1, and we're going to minus the max or the minimum from the max and divide by 2. Okay, I'm going to explain how we're going to do that now. All right, where's that little bit over here that we're writing? All right, so when we want to find the amplitude, we're going to take the max value minus the min value divided by 2. Okay. All right. Max minus min divided by 2. Okay. So I'll show you what this actually looks like. Hello, Ayanda. No worries. Okay. Let's look at what this actually looks like. So my amplitude, guys, tell me, what is my maximum value? If we look at the graph of sine, what is my maximum value? Good. My maximum value is 1, right? So if I want to find the amplitude, I'm going to take my max value, which is 1, minus what is my minimum value? What is my minimum value, guys, on the y-axis? Minus, good, let's say Pile, that's it. Minus -1, and we're going to divide this by 2. So I'm going to end up with 1, a negative and a negative will give me a positive. So that's 1 plus 1, which is 2 divided by 2. 2 divided by 2 is 1. Okay, so this is how we then find the amplitude. We take our maximum value minus our minimum value, divide that by 2. Give me a thumbs up if that makes sense. Okay. Excellent. Okay, so that's how we find the amplitude. All right. Hi, Bo. Like that's our rule. That's the rule of maths everywhere. It's not just your rule. It's everybody's rule everywhere. Hi, T said so. No worries, my sweetie. No worries at all. Okay. All right, Stephen, we can absolutely do another. All right, let's say, because Stephen is asking, let's say my graph sits like this. It goes all the way up, comes through 0, and does this. Right, and I find out that my maximum value over here is 2, and my minimum value is -2. Stephen, tell me, what is my new amplitude gonna be? Remember the formula to find amplitude? Maximum minus minimum divided by 2. I will write it down for you even. Amplitude is max minus min divided by 2. Calculate for me, Stephen, and let me know. Refilwe, how are you doing, my sweetie?
I'm doing well, ma'am.
Okay, what's up, my sweetie? I see your hand is up. Do you have a question for me?
Yes, ma'am. I got lost at amplitude. I don't understand what's happening from
Okay.
amplitude.
All right, my sweetie. So look here. Look at the screen. From 0 to the maximum point. How much is that? How much do we get from 0 to the maximum point? How many units is that?
It's 1.
From here to that maximum point. From the line here to that maximum point. How far up is that?
Oh, 2.
2. That's the amplitude, Refile. That's it. The amplitude is 2.
So what do the calculations mean? Why are we calculating it?
Okay, here's why we're calculating it. Let's say, for instance, one day, Refile, they do this. They take my whole graph, and instead of starting it at 0, they start my graph at 1. They do this. They start my graph all the way up there, right?
Yes.
Now, the maximum value is then 2, and my minimum value is then 0. Okay. If they switch the graph from 2, right? If they move the whole graph up, right?
Yes.
Right. What is my amplitude now? What is my amplitude? Look at the new graph that I've just drawn. What is my amplitude?
It's 1.
How did you figure that out?
Because it starts from 1, I think that's the answer.
Okay, cool. If that works for you, that's awesome. Sometimes they'll leave it at like 4/3, which we won't know what 4/3 is. And then you'll find that they've even flipped the graph and we just can't see exactly what's going on. At some point, Refilwe, we're going to move the graph from left to right. It's going to get very, very messy. Okay, so if you can see the amplitude, you can just write down the number of the amplitude. But at some point, they're going to do other funky things with the graph, and we need to be able to move it. Okay, we need to be able to find the amplitude. Okay, so for now, if you can see it, you can just say what it is. But if you can't see it, then use this formula. Okay.
Yes, ma'am.
Excellent.
So, ma'am,
Oh, sorry. Unmute again. Unmute again for me, my sweetie. Sorry.
like, how do you find the number 2 divided by?
It's just divided by 2. Okay,
Oh,
because
always.
yes, always. It's almost like finding the midpoint. Remember in analytical geometry, when we find the midpoint, we divide by 2?
Yes, ma'am.
The same thing. We're just taking max minus min and we're dividing by 2 to find the midpoint. Okay.
Okay. Yes, ma'am.
All right, my sweetie. Yes, Kemotlotlo's like, ma'am, the graph upside down. Of course, the graph must go upside down. Yes, it will go upside down. It will. I'm sorry, my sweetie. I'm sorry to burst the bubble, but yes, it goes upside down also. Okay, we're going to talk about something that's just as important as amplitude and period, guys. We're going to talk about our domain and range. Okay, so now those are very, very important. Okay, we must always talk about the domain and the range. And Kama, I'm glad to hear that, my sweetie. I'm going to unmute you now. Give me 1 second. Okay. Unmute for me. Hi, my sweetie.
Hi, girl.
How you doing?
I'm not okay.
I'm so sorry. I heard about life science. It wasn't lifing.
Yeah, it was draining.
You know what? I'm glad you're still alive. You came out alive on the other side.
You know, I'm God's strongest soldier at this point. No one can tell me otherwise.
Amen, amen, amen.
Yeah.
All right, but
Ma'am. No, don't worry about it. I was gonna say, like, on like, you know, the topic of like shifting graphs, are we
Yes.
going to be like shifting them today or anytime soon? Because like
Yes.
I realized in class when we were doing them that like I struggled a lot with them.
Okay, so we're going to shift them. In grade 10, we only shift them up and down. We're not going to shift them left to right. Not in grade 10.
Man,
Grade
you
11,
lied.
I tell you, grade 10, we only shift up and down. Grade 11, we shift left and right. Okay.
Man, we were shifting ours left and right, and then we shifted left, and then we shifted up again. It was a lot.
Okay,
It was a
but
lot.
your teacher technically shouldn't do that. They shouldn't be doing that. Okay.
I mean, I know, but like at the same time, we also asked for it because like we also like really don't want to struggle in grade 11 because she said that
Oh, I
like when you
see.
get
So
there,
this
it's gonna
is
get
the
like twice as worse.
This is the self-imposed struggle. So you still can't help people who struggle
Yeah,
on their own. They choose the struggle. You chose the struggle. I don't know how to help you.
man.
Okay. Okay.
But I'm so glad it wasn't in our exam, honestly.
Okay. Yes, it wouldn't be because grade 10 is an SBA year, like a national benchmark test year, and they can't test anything below grade 10. Okay, but we unfortunately, my sweetie, we're only going to be shifting the graph up and down. Okay.
Oh
We're
no,
not
then
gonna-
that's perfect. I understand that fully.
Cool. All right, my sweet.
Thank
I'm
you
sorry,
so
I
much.
can't shift it left and right for you. If you want that, then you can check out our website, check the grade 11 section. Okay, they'll
Sure,
have.
ma'am. Thank you so much.
Okay. All right. Mama just out here fighting a struggle she chose herself. I don't know how to help her. Butle, what's up, my sweetie?
Hi, ma'am. How are you?
I'm good, thank you, my sweetie. What's up?
I'm good. Ma'am, I'm struggling with the domain and range. So, like, I think if I quite understand what actually domain is, like the definition, and also what range is, then I think thumbs up. I'll be
Okay,
okay.
excellent. And you came at just the right time, Bunte, because we're going to talk about it. I don't want you to go away. Okay.
Okay,
Don't
thank
go away.
you.
All right, let's talk about this. Let's talk about the domain. Okay, we said that the domain is always going to be our x values. Yes.
Yes.
Okay, so that's going to be this part of our sign graph that we replace, this x value. Yeah.
Yes,
Okay.
ma'am.
So if I had to say to you, x is an element of real numbers, does that make sense to you?
X is an element of real numbers.
Does that make
Okay,
sense?
yeah, I would say that it makes sense to me. Yes.
Okay, cool. But how far does my graph go? Okay, how far does this graph go? This graph of
From
sign.
the sin one, ma'am.
Yes, this first one, the sign one.
It grows from 0 to 1.
No, not up and down, not in this direction, in that direction. How far does it go?
It goes to 360.
But if I keep drawing the graph, Bunke, what's going to happen if I keep drawing the graph?
The graph will always keep on increasing.
It will keep going up until infinity, yes?
Yes, ma'am.
Good. So we know that our domain tells us that x is an element of all real numbers. But in most tests, Bunke, in most tests, the question will say, given the sign, given y is equal to cos of x, where x is an element of, and your teacher will do this, they will do this, open brackets, 0 degrees, 360 degrees. They will do that for you. Okay, what they're actually saying is you are only allowed to draw my cos graph between 0 and 360. That's actually what they're saying.
Okay. Thank you, ma'am. I understand.
Don't go away. Don't go away. How? Don't go away. We need to talk about the range.
So, ma'am, wait. The domain. So the domain actually, when they ask me, what is the domain of this graph, this in one, it's actually going to be 0 degrees and 360
between 0 and 360, yes. This one is between 0 and 360 because that's what we've drawn, yes? We've only drawn between 0 and 360. But if, let's say, for instance, they move this line over here, and then they make, let me just draw another one, otherwise it's going to get complicated. Let's say, for instance, I'm going too far. Let me move to the side. Okay. Let's say, for instance, they give us this, Bunke, if they give us this, right? And this is 0 degrees, and this is 90 degrees, and this is 180 degrees. And over here, I've got negative 90 degrees, and I've got negative 180 degrees. And we draw the graph on both sides, right? Let's say we're drawing our sine graph, and we draw this half of the sine graph over here, and we draw the other side of the graph over here. And I say to you, Bunke, what is my range? Then you're going to say to me, X is an element of, where did my graph start this time, Bunke? It started at?
180.
Not 180?
0, sorry.
This point?
Minus 180, sorry.
Good. My graph started at minus 180, and it went all the way up to?
180 degrees.
180. Okay, and that is our range. Do you see where we've drawn our graph between negative 180 and 180? That's the range. I mean, that's the domain. Okay, so we need to see how far they've drawn the graph, and that's how we write the domain.
Okay.
I just want you to take special care of one thing, my sweetie. They don't always use X. Sometimes they'll put theta. Okay, because these things are degrees. We're calculating in degrees, and sometimes instead of X, they'll put a theta there. Does that make sense?
Yes, ma'am.
Excellent. I'm glad. Awesome stuff. All right. Everybody else, give me a thumbs up if the domain makes sense, because Bunke just helped us understand the domain. Okay. We just need to see how far the domain goes. Okay, how far the domain goes. How long does it take us to draw a graph? What part of our graph have they given us? Okay, that's what they've given us. So if we look at our mother graph, guys, if we look at our mother graph of sine, okay, tell me here, guys, in this graph, you can put it in the chat. What is the domain of this graph over here? We're going to say X is an element of what? I've opened the brackets for you. Remember, square brackets. Where does my graph start? Yes, Tisetso. Sine, the sine graph, Mawade, this one. Yes, Tisetso?
1.
Oh, no, it starts at which degrees? Which degrees does it start at?
0.
Good, it starts at 0 degrees. And where does it go all the way up to? It goes all the way till?
360.
That's it, 360. And then at the end here, Tisa, so what must I draw? Round brackets or square brackets?
Square bracket.
That's it. Ah, Tisa, so you're a whole G. Wow, excellent. That's it. That's it. Very, very well done. That's what I was looking for. Okay, so our graph is drawn from 0 to 360. I'm so sorry, my sweetie. I wish I'd gotten bigger graphs. They're just so tiny. There it is. I hope it's a little bit better to see. Okay, there. It starts at 0 and it goes to 360. Okay. Lindo Kuche, if I draw round brackets and I put a 0 here, it means that 0 is not included. So we can't draw a dot there. It will be an open space at 0. We would have to have an open space. Rufilo, does that make sense? Actually, Linda Gutle and Rufilo asked the same question. Okay, so round brackets means excluded, square brackets means included. And we need to include 0 because if we put in sign of 0, we're going to get an answer. Okay. Yes, Princess.
Hello, ma'am.
Hello, my sweetie. What's up?
Ma'am, going back to Refilo's question about the difference between the two brackets. So if in the exam we put the round brackets and not the square one, we put the round bracket, will we lose marks?
Yes, 100%. It's wrong. Without a doubt, it's wrong. Okay. Because what you're saying is you're saying that my graph doesn't start there. My graph only starts after 0, and that's not correct. Okay. So, Okay.
Thank you, ma'am.
You're very welcome. Excellent. Guys, square brackets, very, very important. Very important. Okay, let's talk about the range. Now, we know that our domain, we've just spoken about our domain. We said that our domain is our x values, and x will always be an element. Okay? X is an element of however far our graph has been drawn. Okay. Ooh, sorry, Refilwe, don't put round brackets. All right. Our range is always going to be how far our graph goes in the y direction, right? So our y direction, we know that our minimum point is at -1 and our maximum point is at 1. So we would write y is an element of open brackets, square brackets, guys. And we always start with the minimum value. What is my minimum value? Tell me in the chat, what is my minimum value? Mawanda is the only person answering me right now. Good. -1. Anotita, can you tell me what is my maximum value?
Maximum value is +1.
Excellent. +1, square or round brackets?
Square brackets.
Square brackets. Excellent. Well
But
done.
ma'am, I wanted to
You have a
ask you a
question?
question.
Yes,
Yes.
absolutely.
When do we put the round brackets?
When something isn't included. Okay, so if we look at the tan graph, which is what we're going to talk about next, do you notice that 90 degrees is our asymptote, right?
Yes.
So if they ask me for the domain of the tan graph, I have to say x is an element of, it starts at 0, so 0 is square brackets, but I can't include 90, correct?
So that's like because 90 carries on and goes on. Okay.
Good. So I need to go 90 degrees, and then I need to put round brackets because I can't include 90 degrees. Okay.
So the square brackets just says that this is how far the graph goes, and the round
Good. This
brackets
point, yes.
it goes further.
Exactly. So square brackets is this point where my graph goes, this point is also included. Round brackets means it goes right up to that point, but the point itself is not included.
Okay. Thank you very much, ma'am.
Very welcome. Awesome stuff. All right. I'm glad everybody's, are we all on board, guys? Give me a number from 1 to 10, 10 being I understand everything, domain, range, period, and amplitude. Give me a number because we're about to put this into practice, guys. We're about to put it all together. Okay, excellent. All right. For those of you who are like 5, 9, 9.5, it's fine. Okay, we're going to get there because we're going to try an example now, and I'm going to add in a bit of a twist. Okay, I'm going to add in a bit of a twist as we go along. All right. Now, we know what our graph, our mother graph of sine x looks like. It goes from 0 all the way to 360. Hi, Bo. Slay Queen, Kanti, what happened? Nkechi, what's up, my sweetie?
Hi, ma'am.
Hi, my
So,
sweetie.
I wanted to ask what the amplitude of the tan graph would be, if there is one.
There's no amplitude. A tan graph doesn't have, because it goes on forever in both directions, yes?
Okay, thank you, ma'am.
Good. Very welcome, my sweetie. That's all we needed to know. Yes, Slay Queen.
Yeah, I don't know if it's the formulas that you like put out, because like I'm not used to doing it with the formulas. Like,
oh, okay.
Our teacher would just like literally just say you have to know it.
Okay, that's fine. I mean, you can see it. Sometimes it's intuitive and you can see it, and then you don't have to go through that. But you know, if you're struggling to see what's happening, it's easier for some people to use the formulas. So if you can see the range, write the range. If you can see the domain, write it down. But if the amplitude is going to be difficult for you to find, then you can use the formula. Okay, but if you can see it, there's no need.
Girl, bye. Oh my gosh.
Okay.
Yeah, thank you, ma'am.
All right, my sweetie. Guys, hold on. What do you mean? Those square brackets look too clean. I drew them myself, Anotida. At least I can draw square brackets. Nah, I can't draw graphs, but I can draw square brackets at least. Okay, all right. Let's talk about this graph of f of x, which is 2 sine 2x plus 1. Okay, we're going to do this. We're going to do this, guys. We're going to draw the graph. We're going to sketch the graph of 2 sine 2x plus 1. But we are also going to move, we're going to answer a couple of questions about the graph as well. All right, so this plus 1 tells me to move the whole graph up 1. Move the whole graph up 1. Okay, up by 1. So my graph is no longer going to start at 0. My graph is going to start here. Okay, it's not an asymptote. Not in this graph, Mawande, it's not an asymptote. Okay, the sine graph doesn't have an asymptote. Okay, thank you, teacher Nelly. Okay, so this line that used to be over here is now up here. All right, and then we're going to remember all the points that we took from our mother graph, guys. We need the point 90 degrees. We need the point 180 degrees, 270 degrees, and 360 degrees. Right, I'm going to add in a couple more because we know that some things are going to happen here. 45 degrees, 135 degrees, 225 degrees, and I don't know what this number is. It's 315. Yeah, 315 degrees. Okay, cool. Now I'm going to ask you guys, what is the period of my graph? What is the period of my graph? Remember, the period of my graph is determined by this thing here in the middle, right? How many graphs am I going to fit in 360, guys? Anotida, be careful. Be careful. Remember how we calculate for the period. In order for us to calculate for the period, we need to take 360 and divide it by the number of graphs we can fit in. We know we can fit in 2 graphs. So in order to find the period, guys, we're going to go period is equal to 360 divided by 2. Now, I'm going to ask you guys again, what is the period of my graph? Pop your answer in the chat. What is the period of my graph? That's it. It's 180. Awesome, guys. Amazing, Amawande. Well done. Wow. So we know that we are going to finish a graph at 180. We're going to finish a graph there at 180. Right. Now, this over here is my amplitude. This is my amplitude. Okay, this tells me how far up from the start point my graph goes. So if my graph started at 1, what is my sorry, let me put that together again. If my graph starts at 1 and my amplitude, my max value is 2 units from my start point at 1, what is my max value going to be? What is the max value of my graph going to be, guys? If my graph starts at 1 and my amplitude from here to there is 2 units, what is my max value going to be over here? It's not going to be 2. I've gone up 2 units, guys. I've gone up 2 units. Excellent. My new max value is going to be at 3. What about in this direction? If I have to go 2 units down in this direction, what is my minimum value going to be? What is my minimum value going to be? It's not going to be -3. Remember, I'm moving from 1 and I'm going 2 values down. Woo, I'm getting conflicting numbers. Okay, so if I move 1 down, I'm back at 0. And then another one down will put me at -1. Good. It will put me at -1. Good. So that is my new min and my max value. So I know that the point that I need to make it to is 90, or I'm lying. My value must be at -1 and 3. That's where my graph needs to go. Okay. I know, Ritmeti, it happens. I know. Yes, Didi.
Hi, ma'am. I just wanted to ask, how do you determine like the max and minimum value when you're given this, should I say formula? Yeah.
Okay.
Or when you're
so
given the
remember-
question.
Okay, so this part over here will determine where my graph is going to start. Okay, so my graph will start at 1, right? And my amplitude, if my amplitude is 2, I need to go from where my graph is going to start, and I need to go 2 up and then go 2 down. Okay, and that's how I can determine the maximum and the minimum point.
Okay, thank you, ma'am.
All right. All right, my sweetie. Bunke, how can I help? Okay.
Ma'am, like, since it's been like, I think my 3rd week since I'm attending like the Watobe class. So I wanted to ask you if like, don't you mind like giving us like maybe 2-3 sums, like just to do them for practice, because
Okay.
wow.
I can do that. And I actually used to do that. I don't know why we stopped doing that for a while. I can give you that. It's just that we have quizzes on Wednesday, and I don't want to overload you guys because I know you already get homework from school.
Okay, ma'am.
But I'm happy to do that. Okay, I'll do that from Wednesday on. Okay, is that okay?
Thank you.
Okay. All right, my sweetie, I'm happy to do that. All right, guys. Okay, so I want you guys to go to your calculator. Do we agree? If I put 45 degrees in here, I'm going to get 2 times 45, which is 90 degrees. What is sine of 90 degrees, guys? Thank you, teacher Nels. We actually are out of time. All right, maybe we should park it. Maybe we should park it and we'll pick it up again here. Okay. Sure, guys. Okay, we're going to finish up again on Wednesday from this point because whew,